All right, in this video, we're going to be going over the answers to the Unit 1, Lessons 1 through 3 quiz. So over here, the first question on the quiz said that we need to solve the equation by graphing, and if exact roots cannot be found, to state the consecutive integers between which the roots are located. And we are looking at the equation negative 2x squared plus x plus 2 equals 0. So the first thing that I would think about when I'm looking at this problem is that the a value is negative, so I know the graph faces down. So I know B cannot be the answer and D cannot be the answer. It has to either be A or C. So what I'm going to do first is I'm going to take my equation and I'm going to dump it in the TI-83 calculator. So I've got my calculator over here. We're going to go to y equals and type negative 2x squared plus x plus 2. And then what I want to do is go and look at the graph so I can see what the zeros are. So I'm going to hit zoom 6 will take us to the standard 10 by 10 window. So I can see here, that looks pretty similar to both A and C. But let me go and find what these two zeros are. So I'm going to go second trace, find the 0. For my left bound, I'm going to go somewhere to the left of this first point. Right bound somewhere to the right of it. Enter. Guess, hit enter. My first answer is negative 0.78. And I see that's between 0 and negative 1. And let me see if I can change my viewing window. Part A says between 0 and negative 1, and B says 1 and negative 1. And I just saw that it was between 0 and negative 1, so I already know it's A. I don't even have to look at the other value. So that tells me that my answer to the first question is A. All right, going down to question 2. I'm doing the same type of thing on question 2. I have the equation now negative 2x squared plus 5x plus 8 equals 0. So again, I see A is negative, so right away I know it can't be B and it can't be C. It's either A or D because the graph faces down. So I'm going to come back over here to my calculator and put in this new equation. We've got negative 2x squared plus 5x plus 8. And again, I'm going to go and look at the graph. And I'm going to find, this time I'm going to find this one on the right, found the 0 value over on the right side this time. So we're going to go to second to trace, calculate the 0. For my left bound, I need to be somewhere to the left of that value where it crosses the x-axis. That's good right there. Enter, somewhere to the right now. That's good. Guess, just hit enter, and I get 3.6. So that's between 3 and 4. So I come back over here and look at this. It says one solution is between negative 1 and 4. The other one says 3 and 4. We know our answer was 3.6. That's between 3 and 4, so it has to be D. So we're going to come over here, and our answer to number 2 is D. Now we're going to go on to question 3. Question 3 says that we need to, let me pull the window up a little bit, determine whether the given function has a maximum or minimum value, and then find the maximum or minimum value of the function. So right away, again, you look at A. A is positive this time, which means that the graph is going to face up. It's going to look something like this. So I know that this graph right here, you can see this point, that would be the minimum value. So I can rule out any option that says maximum. So I can rule out A and I can rule out B. So I know it has to either be C or D. What I need to go ahead and do now is find negative b over 2a. So I'm going to write down that my a is 1, my b is negative 6, and my c is positive 6. And then you're going to do negative b over 2a, and when you get negative b over 2a, that will give you the x value. Let me move this out of the way. Move this up here. Your x value is going to be, let's see, negative b would be the opposite of negative 6, so positive 6 divided by 2 times 1. 6 divided by 2 is 3. So x is 3. And then to find the minimum value, what we need to do is take 3 and plug it in the equation. So I'm going to come back over here to the calculator, go back to the main screen, and I'm going to plug in 3 in this equation. So I've got 3 squared minus 6 times 3 plus 6. Just plugging in 3 in the equation, and I get negative 3. That means the minimum value is negative 3. So back over here, that means I know my answer for number 3 is C. Next question, 4. A music store sells CDs for $8.50. On average, the store sells 90 CDs every day. For each 50-cent increase in the price of regular CDs, the sale of CDs will go down by 5. So that basically means that if we raise the price to $9, we would only be able to sell 85 CDs. And if we raised it to $9.50, we'd only be able to sell 80 CDs, and so forth. So we need to find what should the CD price be to get the most income from the sales. So we had a homework problem like this, and when we did that, we set it up like this. The first thing we're going to do is we have our 2 sets of parentheses. Let me draw another one, and another one, and another one. Okay, and in our first one, what we start off is the basic price was $8.50. The pen doesn't want to draw 50 cents. Remember, that's 8.50. And then we are going to add to that. I'm running out of space. I'm going to pull this stuff over here. We're going to add to that the price. Since this is $8.50, we're going to add to that the 50-cent increases. So that would be point. Man, this thing really does not want to do any decimal values. Let me turn this into a really small decimal value. This is not working. Okay, let's just pretend this says 8.50 plus 50 cents times X. That's our first thing. Our second thing is going to be the number of CDs, and we start off with 90 CDs. And every time we raise the price, the number of CDs goes down by 5, so minus 5 times the number of increases that we're going, the number of price increases we're going to do. So this equation, 8.50 plus 0.50x, I know you can't see the decimals, please pretend they're there, times 90 minus 5x, we're going to dump that equation in the calculator. So coming back over here, and we're going to type 8.50 5 or 8.50 plus 0.50 x, close the parentheses, times 90 minus 5x. And then we're going to go to the graph. Zoom 6. Notice you can't see anything. If you hit trace, it tells me when I'm at 0, the equation's all the way up at 765. What I need to do with that is I'm going to change my window up to a little bit higher than 765. I'm going to go up to 800. And because I'm going up all the way from -10 to 800 in the y direction, I'm going to change my y scale. So this essentially is what you count by, what each unit is. I'm going to count by 100 instead of by ones. And go back and look at my graph. And you can see that the graph faces down. It's got a maximum somewhere around here. So I want to find that maximum value, because if I can find the maximum value, that's going to tell me how many of these 50-cent price increases I need in order to find the maximum sales for the music store. So to find the maximum, you're going to go second, trace, and maximum, number 4. And again, it's going to be left bound, right bound, and then guess. So for your left bound, you want to be somewhere to the left of it. I'm not really sure where it is. I'm going to go somewhere over here to the left. I know you can't really see it because it's kind of blocked by the equation up here, but for my right bound, I'm going to come over. Hopefully you can see the cursor moving a little bit. If you watch the y values, you see how it's going down. I think I'm definitely below the maximum now. So I'm going to hit enter. For my guess, I hit enter. And it tells me the maximum is at 0.499999. That basically means 0.5. So that means I need half of one of these 50-cent increases. Half of a 50-cent increase would be 25 cents. So we're going to increase the price over here from $8.50. We're going to increase it by 25 cents, which means that our final price is going to be 8 point. Can't do a point still. 7, 5. I'm sorry, my numbers just are ugly on here. But the final price, again, would be $8.75. Okay, question 5 says the path of the water from a sprinkler is modeled by a quadratic function, -2d squared plus 6d plus 4, where h of d is the height of the water in feet at a distance d feet from the jet. Find how far from the sprinkler the water hits the ground. So what we're going to do again is we're going to come over here to the calculator and we're going to type in our equation, -2x squared. Remember, you have to use x when you're on the calculator. You can't use the variable that's in the problem. Plus 6x plus 4. And I'm going to go back to my Zoom 6, my standard window. I see it crosses somewhere over here. This would be a negative distance this side, so I want this 0. So second trace, 0. I'm going to move my cursor somewhere to the left of that value. That's good. Enter. Somewhere to the right now. That's good. Hit enter. Guess. Hit enter. And my answer is 3.56. So how far does the sprinkler, how far does the water hit the ground from the sprinkler? It would be 3, I'm not even going to write point this time, but 3.6. And let me, come on thing, make that F. Whoa. There we go. Now we got an F. And we're going to make a T now. I might be able to make a T. There we go, 3.6 feet. Okay, we're going to pause the video here and pick up with questions 6 and 7 in the next video because I'm about to run out of time for recording.